Hello, I'm going to talk about a use case from the financial services sector for EazyML. Before I dive into the differentiators of the EazyML platform, Augmented Intelligence and Explainable AI, I would like to show you what this dataset is about. This dataset is from a large global bank that has been around for several decades, with very regimental processes for underwriting. The data has been anonymized to protect the privacy of its customers. What you are looking at is a historical performance of borrowers in a bank's portfolio. Every single record here belongs to a borrower. They have lent money to these borrowers back in the summer of 2018. By the summer of 2020, some of these borrowers had defaulted while others continued to perform. So despite having regimental guidelines in place, there were still plenty of defaulters. The challenge is to learn from this past and apply that knowledge towards future applicants. Can we learn from this dataset and make better decisions when it comes to underwriting? What we do is take this dataset and load it onto the EazyML platform and go through the entire end-to-end process: data pre-processing, model building, running predictions, and finally, running explainable AI. I'm going to highlight the differentiators of EazyML that set it apart from other available platforms. So let's take this dataset, upload it on the EazyML platform. Here is the landing page. I have already uploaded this dataset and gone through the end-to-end pipeline. Let me open it. This was the dataset which I have uploaded. You can see the entire processing here by executing this trace functionality here. That's the beauty of this platform. You can use it for audit purposes in your reviews. It keeps track of the entire history of everything that was done with this dataset. What were the choices you made when you uploaded this dataset? What was the choice of the identifier column? What columns were discarded and what were retained? The entire process from auto-determination of data types to outlier removal. It is all here in Trace. In this case, the outcome happens to be whether the borrower is going to default or not. When you go through the model building process on the EazyML platform, much to the enterprise's pleasant surprise, there is a repository of the assets that the user is building. We are looking at training datasets, models, and predictions. We can find the model asset in the repository. I'm going to quickly show you the model building process and the entire pipeline. So again, you go to the far right and click on Trace. You get to see all the choices that I made while building this model. This is a classification problem because the outcome is categorically natured. You want to know the chances of a borrower defaulting or performing. Here, they go through the entire feature selection process and in the end, build the model. EazyML builds most of the popular models in the enterprise world. You can see the list of those models, including neural networks, support vector machines, decision trees, random forests, and so on. And then, it is going to build and optimize these models for their respective hyperparameters. In the end, it is going to recommend the very best model. In this case, it happens to be AdaBoost decision trees with 68% accuracy. Because of EazyML auto-optimizing for hyperparameters and running through the possibilities of all the models that it has, it is able to bring the very best model for your predictions. As data scientists, you may try to build these various models and try to optimize parameters on your own. That process is painstakingly long. Using EazyML, it was accomplished in a few minutes. You also get to see the important predictors that play a role in the outcome. After you build the model, you're ready to predict from the model. I have the predictions made of this dataset right at the top. I'm going to access the results from the past in this dataset. Those predictions are in here, and you can scroll to the right to see them. Whenever the predictions are correct, you will see green, and when they are incorrect, you will see red. But more importantly, What you want to know is why it predicted the way it did. Imagine there is a borrower that has come to you seeking loans. This particular customer has been banking with you for a decade or so. For this particular borrower, let's see what explanations EazyML comes back with. I can try any of the traditional explainable AI like Lime or SHAP, but the most you can get in terms of explanations is the importance of various predictors. For this borrower, all platforms including EazyML will predict default. But what's more important is to know why these models predict default. The relationship manager on any of the other platforms, when asked for an explanation, would simply say, "Sorry, you are denied, and the deposit sum is the reason." Now, the customer has been banking for 2 decades and is obviously unhappy. They might say, "What do you mean denied? What can I do? Do you want me to increase the deposit sum? Is it not adequate?" Now, unlike with other platforms, EazyML does agree that the deposit sum played an important role, but also provides an explanation for the deposit sum and other factors. Now let's look at the explanation here. This time, with EazyML, the relationship manager says, "Sorry, you are denied because your deposit sum is slightly lower, and your credit score is just below the cutoff too." Of course, there are standard ways to increase the credit score, and any positive movement will push it over. If you do these few things, and come back to me in a couple months, you should qualify. Through this richer experience, the customer leaves with content and a way forward. However, there is still something that can be very troubling for the customer. What if they do their tasks and return after a couple months, but still get denied? Those who have worked with platforms like Lime know other platforms can give you the reasons but can't answer the question as to how much you can believe in the explanation. When the relationship manager offers the explanation, how much should the customer believe in it? How confident are you that when I work on these tasks, that there is a reasonably high chance that I will be able to qualify? To be honest, almost everyone doesn't want to give you an answer, whether it is Microsoft with Azure AI, or Word Excel, or Lime. EazyML is unique with its patent-pending confidence score. In this particular case, about 80% can. The relationship manager can confidently go back to the customer and say that there is an 80% chance that if you work on these few issues identified with your application, you will qualify. With that confidence and specific recommendation about how to come back and qualify, the customer is much more satisfied and the bank gets to retain their customers. They both have a very different and enriching experience. That is why the confidence score at EazyML is gaining so much traction and makes EazyML stand out in the comparative landscape. Now that we have looked at the explainable AI, a key differentiator for EazyML, let's look at another key differentiator which makes the data transparent. We are talking about augmented intelligence. When we go over to the EazyML platform, right here under the features, we can see augmented intelligence. The feature makes the data transparent opposed to explainable AI, which makes the model transparent. Imagine the same data set, but the use case this time is somewhat different. What if the bank wanted to enhance its existing rules and processes to make better decisions? As I have said, this bank is well known and has rigorous processes developed over the years. Yet they are standing in deep waters. There is clearly room for improvement in their guidelines and processes. What if there was a function that can take this data and reveal the insights about commercial underwriting that can be used to tune the existing rules and guidelines so that they can perform better? The objective is to reduce defaults and land more for the same risk. What we do is take the same exact dataset, go over to EazyML, and this time we build the augmented intelligence model. I have built the model over here. The augmented intelligence reveals those insights discovered from the dataset. The very first column you are looking at is the outcome of your interest. 0 is for no and 1 is for yes. The second column is for when you have these insights expressed as rules and conditions. Here is an insight. There are about a few conditions here under which the applicant is likely to default, such as if a loan applicant has a poor deposit sum and the credit score is lower than a certain threshold. The sentiment score expressed there is in the neutral or negative range. Now the question is, how likely is an applicant going to default? What is the measure of trustworthiness of the insights? In this case, it is 71%. Now you may ask, what is the confidence in the confidence score? Why should I believe in it? Let's just say you validate it yourself. Take these conditions and apply to your original dataset. These conditions can be transformed into SQL queries, or you can implement these conditions as spreadsheets. Apply these conditions and see the filter bracket for yourself. EazyML also allows you to validate confidence scores for yourself and validate those insights. Let's go back and look at this insight again. Here, EazyML has applied those conditions in the dataset and filtered those records. So you get to see those insights along with their confidence score at the top. But more importantly, all of the records from the dataset get filtered out after applying the conditions. The very first column is where you get to see the outcome. As you can see, most of these records do indeed belong to the defaults. You can see for yourself which particular applicant is a default. A reassurance in the confidence score that it is truly reflective of the patterns which are discovered by EazyML. That is the second differentiator from EazyML, augmented intelligence, which makes the data transparent. Thank you so much for watching the financial services use case demo. Please visit our website www.eazyml.com to see demos of other various industries such as manufacturing, healthcare, retail, and others.